Hello and welcome to the Reigate College Year 1 Core Pure Booklet 1 video on sigma notation and sums of series. So we're going to look at a useful notation, sigma notation. This is the Greek letter sigma, and in maths we use it to mean the sum of a set of things. So if we've got the sum of the r's from r equals 1 up to 10, this notation means start off with r being 1, and then r it becomes 2, r is 3, and we evaluate what r is going to be, r is 4, and so on all the way up to r being 10. And we could work out what that total was. Doesn't have to be r in the sigma notation, it could be a different expression, so r squared. So if we had the sum of the r squareds from r equals 1 to 6, we would start with r is 1, and that would be 1 squared, plus when r is 2, 2 squared, plus r is 3, 3 squared, r is 4, 4 squared, 5 squared, plus 6 squared. So this is a handy notation and is quicker than writing this out every time. Doesn't have to be a single term, we could have an expression here. So I've got here r cubed plus 2r. And I've changed these numbers here, these are called the limits. This time we're going to start with r equals 3. So this is equal to 3 cubed plus 2 times 3 plus, then r becomes 4, 4 cubed plus 2 times 4 plus 5 cubed plus 2 times 5 plus 6 cubed plus 2 times 6. And we could work out what this was equal to using a calculator or using the method that we're going to learn in this chapter. A couple of things to be aware of. You can have the sum of r equals 1 to 8 of 5. That's a little bit confusing at first, but just follow the same method. This means when r is 1, I'm going to write down 5. When r is 2, I'm going to write down 5. When r is 3, I'm going to write down 5. I'm going to keep doing that. 1, 2, 3, 4, 5, 6, 7, 8. 8 times. So I have got 8 lots of 5 here, so that is 40. So if I've got the sum of a particular number, change it to 7, from r equals 1 to 10, that would be 10 lots of the 7, so that would be 70. That's what that sum would be equal to. Some of these sums have particular formulae that we can use to work them out. So if I want to find the sum of the numbers from 1 going up in steps of 1, 1, 2, 3, 4, 5, all the way up to n, there's a particular formulae that says that's going to be a half multiplied by n multiplied by n plus 1. And there are various ways to solve this. If you've done any work on arithmetic series, you will be able to recognize this formulae. But for the beginning of this set of work, we're just going to take that formula as something that's given to us. So let's have a look at some questions from the workbook. So at the top here we've got this formulae that the sum of r is a half n plus 1. These formulae for r squared and r cubed we'll come on to later. So let's have a look at how this works. first question is the sum of 3r minus 1 from r equals 1 up to 20. So we split this, and we can take a factor of 3 out, because if we do 3 times the r's and find the sum of all those numbers, that's the same as doing the sum of the r's and multiplying that by 3. So this is going to be equal to 3 times the formula for the sum of the r's. So that's going to be a half multiplied by n, which in this case is 20, multiplied by n plus 1, which is 21. Minus, now this is the sum of 1 from r being 1 up to 20, so that's 20 lots of 1 minus 20. So working this out, we've got 3 times 21 is 63, multiplied by 10, so it's 630 minus 20, which is 610. Or use your calculator. Next example, we've got the sum of 4r minus 1 from r equals 1 up to n. So this is just the same as the last one, different formula inside. So this is going to be 4 times the sum of the r's, from r is 1 up to n, minus the sum of 1 from r equals 1 up to n. So when we work this out, we get 4 times n over 2, or half n, times n plus 1, minus, and this is going to be n times 1, n. You need to tidy that up a little bit. This is 2n, n plus 1, minus n, which we might write as 2n squared. 2n minus 1n is n. And there's our algebra expression. So if I wanted to find that sum, say for n equals 100, I could just put 100 in here. This formula will give me that sum. Last 2 examples. Got the sum of 5r plus 3. This time we're summing up to 2n. So this time we need to take the value for n as being 2n. So we've got here, this is the sum of 5 times r from 1 to 2n, plus the sum of 3 from 1 to 2n. So we just use the formula that we've already used. So 5 times a half times n. Now remember that n is 2n, times n plus 1. Again, this is going to be 2n plus 1. Plus, we've got 3 2n times, so it's going to be 2n times 3. So then we've got a little bit of tidying up of algebra to do here. That half and that 2 are going to cancel. So I've got 5n on 2n plus 1 plus 6n, which is 10n squared plus 11n. That's my final expression. Last question. We need to find the sum from 20 to 40 of r. So what we need to think about here is, if we're doing this, that's the same as finding the sum from r equals 1 to 40, but that would be too much. So I need to take away the sum from r equals 1 up to 19, and be careful there, think which term you want. So we want the sum from 1 to 40, which is going to be a half multiplied by 40 multiplied by 41. Take away the sum up to 19, which is a half multiplied by 19 multiplied by 20. And when you work that out, possibly using a calculator, you get 630.